Today we are going to be learning about similar polygons. So similar polygons are going to be polygons with the same shape, but they're going to have a different size. So polygons we know are going to be similar if their corresponding angles are congruent. So if we have two triangles and all three of their angles are the same, but their sides are different, they can still be similar polygons. And then two are corresponding sides are proportional. So going off of that first statement, so we have those two triangles, all of their angles are the same, but their sides are different, then we would go on to check if their sides are proportional. So we would set up a proportion similar to what we did on the practice before this. The ratio of corresponding sides is called the scale factor. And then if polygons are similar, then their perimeters are also proportional. And a perimeter is when you add up the length of that outside of that shape. So for scale factor, we're going to look at an example. I have triangle ABC and triangle DEF. And these two triangles are similar. They have congruent angles, so angle A and angle D are congruent, angle B and angle E are congruent, and angle C and angle F are congruent. But they have different side lengths. So their corresponding angles are congruent, and their corresponding sides are proportional. So we're looking for that scale factor that shows that their sides are proportional. So we want to find the scale factor of triangle ABC to triangle DEF. So we're going to choose one side from each of these triangles, and it needs to be the same side or the corresponding side in each of them. So looking at triangle ABC, I'm going to take my first two letters because this is where orders matter. So AB, I'm going to look at side AB, this one here, which is 8. AB equals 8. And then I need to look at that exact same side in my second triangle. So if I took the first two letters of this triangle, I have to take the first two letters of my second triangle. So it's going to be DE on my second one. DE is going to be 12. Now I'm just going to set up a ratio. So I'm going to put 8 over 12, and then I am simplifying if I'm able to. So if I can simplify, I want to divide these both by the same number. They're both divisible by 4. So 8 divided by 4 is going to give me 2. 12 divided by 4 is going to give me 3. So my scale factor is going to be 2/3. Now I'm looking at the scale factor of triangle DEF to triangle ABC. So I switch the order of them. So I'm going to look at the same exact side. So looking at DE, we knew DE was 12. And then looking at AB again. And we know AB was 8. Once again, we're going to set up that ratio, but since triangle DEF came first, DE is going to go on the top. So it's going to be 12 divided by 8. And then again, we're simplifying this if we can. We know they're both divisible by 4. So 12 divided by 4 gives me 3. 8 divided by 4 gives me 2. So my scale factor here is 3/2. And you can see that these are just reciprocals because it just depends on which triangle came first. So in this one, 2 is on top because ABC came first. On this one, 3 is on top because triangle DEF came first. And then lastly, we're going to look at the ratio of the perimeter of triangle DEF to triangle ABC. So for triangle DEF, our perimeter is going to be 12 plus 15 plus 21. And then for triangle ABC, it's going to be 8 plus 10 plus 14. So when we add those up, I have 12 plus 15 plus 21. That's going to give me the perimeter of triangle DEF is 48. And then when I add up triangle ABC, I have 8 plus 10 plus 14. That's going to give me the perimeter of triangle ABC is 32. And then I'm going to set up in a ratio with these. So it's going to be 48 divided by 32. And I want to simplify if I can. And I know that these are both going to be divisible by something. So I need to figure out what the top and the bottom are all divisible by. And these are both going to be divisible by 16. So 48 divided by 16 is going to give us 3. And 32 divided by 16 is going to give us 2. So our scale factor here is 3/2. And you'll notice that these two here are the same, because we were looking for the scale factor of the exact same thing. We just set it up 2 different ways. So you'll still get the same scale factor every time. And then a similarity statement. So a similarity statement is going to be similar to our congruent statement, but we're saying that these triangles are similar. So the order still matters. And our symbol for similar is going to be a squiggle, like that. So a valid similarity statement must match corresponding angles and sides. So if we are looking to write a similarity statement for these 2 triangles, I'd write my first triangle, and I'm going to pick ABC, just keep it in alphabetical order. And then I'm going to write my similar statement, my similar symbol. And then I'm going to write my second triangle. So I have triangle, and then I put angle A first, so whatever angle is congruent to angle A needs to come first in my second triangle, so that's going to be D. Then I put B second, this one here is going to be congruent to angle E, so angle E has to come second. And then lastly, angle C and angle F are congruent, so F needs to come last, and that is going to be my similarity statement. So for example number 1, or problem number 1, we are going to list all congruent angles and write a proportion that relates the corresponding sides. So we're going to start with our angles. So we have triangle JKL is similar to triangle PMN. So I'm going to go with my first angle. My first triangle is going to be angle J. And I know angle J is going to be congruent to whatever the first angle that comes in my second triangle. So that's going to be angle P. Then I'm going to move on to my second one, which is going to be angle K, my first triangle, and that's going to be with the second letter of my second triangle, so that's going to be congruent to angle M. And then last letter is L, so angle L is going to be congruent to last letter of my second triangle, so angle N. Now I am going to set up a proportion that relates the corresponding sides. So my first side is going to be my first 2 letters, JK, and I'm going to set that up as a proportion. It's going to look like a fraction. It's going to be over the same side of my second triangle. So if JK were my first 2 letters, I need to take the first 2 letters of my second triangle, so PM. So JK over PM is going to equal, we're going to move on to my second side. I'm going to take those last 2 letters, K and L. They're going to be proportional to the last 2 letters of my second triangle, so M and N. And then my last proportion, I'm going to set up. Last part of the proportion is going to be my last side, so that's going to be my outer 2 letters, so JL. And then my outer 2 letters on my second triangle, so PN. And there's my proportion for all 3 sides of these 2 triangles. You're going to do that same thing for numbers 2 and 3. So you're setting up all the congruent angles and then writing a proportion for all the sides. Just going to go over a few more examples with you guys. So for number 4, we have, if the figure below are similar with a scale factor of 2 to 3, find the value of x. So if we know the scale factor is 2 to 3, we're going to write that as a fraction or ratio. And then we're going to set that equal to, and we're going to take and set up with these two sides. So I have the left side of this polygon here and the left side of this polygon here. I'm going to write those into a ratio here. So it's going to be 42 over x. All I'm doing here now is I'm going to cross multiply. So I have 2 times x equals 42 times 3. And then 42 times 3 is 126, so 2x equals 126. Dividing both sides by 2, I'm left with x equals 63. For number 6, we have triangle ABC is similar to triangle DEF, and we want to find the value of x. So we don't know the scale factor, but we can set up a proportion because we know at least 3 of the sides, and we know that they're similar. So we're solving for side AB. So I'm solving for side AB, so I'm going to put x first. We need to figure out which side in my second triangle AB is similar to, or proportional to. So if AB comes first in my first triangle, I need the 2 letters that come first in my second triangle. So it's going to be side DE, so this one here, 25. So I'm going to put x over 25. Set that equal to. And then in the top of my second fraction, I need to have the other side from the same triangle that's in the top of my first one. So if x is in the top here, 28 needs to go on the top of the second one. And then 28 is side BC, so my second 2 letters, so that needs to go on top of second 2 letters, which is going to be EF or 20. Now we're just taking cross multiplying to solve this, so I'm going to have 20 times x equals 25 times 28. And then 20x equals 25 times 28 is going to give me 700. Dividing both sides by 20, x is going to be equal to 35. And then one more example for you guys. So number 8, if triangle AGM is similar to triangle KXD, we want to find the value of x. So we're going to set up a proportion. So the first side I know is side AG. So it's going to be 32. And I need to put that on top of whatever side is in the same order as AG in my second triangle. So it's the first 2 letters in my first triangle. I need the first 2 letters in my second triangle. So KX. KX is going to be x plus 3. I'm going to have 32 over x plus 3 equals, and then my other side is GM of my first triangle, so that needs to go on top. So 36, and GM is the second 2 letters of my first triangle. So I need the second 2 letters of my second triangle, XD. XD is going to be right here, which is x plus 6. Now we're going to take and cross multiply. So I have 32 times x plus 6 equals 36 times x plus 3. Now we're going to go ahead and distribute. So 32 goes to both of those, 36 goes to both of those. So 32 times x is giving me 32x. 32 times 6 is 192, so 32x plus 192 equals 36 times x is 36x. 36 times 3 gives me plus 108. Then I'm going to take and move some things around. So I'm going to subtract 108, those cancel, subtract 108. I'm going to move up here so I have more room. So I'm left with 32x, and then I have 192 minus 108, which is going to give me 84, equals 36x. I'm going to move the 32x over. I'm left with 84 equals 4x. Dividing both sides by 4, x is going to equal 21.